Hello, hello. I welcome you all to this online tutorial on carbonyl compounds. Last time we went through introduction to carbonyl compounds, and we are going to proceed with what? I think it has to be isomerism within carbonyl compounds. Allow me share my screen. My device is a bit slow. It's a bit slow. I think I have shared. Yeah. So this is isomerism. Isomerism within carbonyl compounds. So in senior 5, you were taught different types of isomerism. However, in this case, we are going to concentrate on structural isomerism. So I want to say that carbonyl compounds exhibit all the three types of structural isomerism. They undergo all the three types of structural isomerism. And recall that these three types of structural isomerism we have, I abbreviate them using CPF. So we have chain isomerism, then there is position isomerism, and then there is functional group isomerism. Those are the three types of structural isomerism which are undergone by carbonyl compounds. Don't forget that for chain isomerism, isomers here, don't forget that here, isomers differ in the structure skeleton of carbon. We have those which are branched and those which are straight chain. That is for chain isomerism. Then position isomerism, here compounds differ. They differ in the position. They define the position of the functional group. They define the position of the functional group. For example, in one I can have a situation where the functional group is at position 1, then in the other I have a situation where the functional group is at position 3. So for position, just as the name sounds, they just define the position of the functional group. Then functional group isomerism here, isomers. Isomers differ by type of functional group. They differ by type of functional group. Yeah. Now these are just basic definitions because this information was taught in senior 5. But before I generate my examples, I just want to give you an intuition of what I mean by chain isomerism, position isomerism, and functional group isomerism. Then now, having commented on what they mean, I can take some few examples so that you appreciate this better. For example, consider the compound, let me consider the molecular formula. Consider the molecular formula. Which one should I take? C5 H C5H10 O. Now you may ask me how have I generated this? Don't forget that aliphatic ketones and aldehydes conform to CN H2NO. So to have that molecular formula, I have considered N equals 5. So we have the following. So I'm going to use that formula to generate the different. So consider the molecular formula this, then we generate chain position and functional group isomers and functional group isomers. So I start with the chain. Chain isomers define the structural skeleton of carbon. You can have one that is branched and another one which is a straight chain. So out of C5H10O, I can generate C3 CH3 CH2 CH2 CH2. How many are those? Those are 4 carbon atoms. Then CH CHO. That one. You can see that the carbon atoms are 5. The carbon atoms are 5. Hydrogen atoms are also 5. 1 oxygen. Then I can also decide to branch, create a branch. To create a branch. If I'm to create a branch, then I should have 4 carbon atoms within the parent chain, i.e. CH3, CH, CH2, CHO, then a branch here, CH3. You can count the carbon atoms. You can see that there are 5. You can as well count the hydrogen atoms. The hydrogen atoms are also 1, 2, 3, 4, 5, 6, 7. The carbon atoms, these are 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so we can also have this one. So you see that I have one that is a straight chain and another one which is branched. So these are chain isomers. I'm not saying that these are the only examples I can formulate. I can formulate other examples. Yeah. I can also have a case, a situation. Let me also include it. Where I have 3 carbon atoms within the chain. For example, CH3, then C, CHO. Then create a branch here. And a branch up. Like that. Then extend here. Extend this bracket. So those are chain isomers. Then for position, now you can easily see that these are aldehydes. I have only considered CHO, CHO, CHO. One can as well consider ketones. I can also have ketones. I can also have ketones. How? Let me also do it here. Alternatively, we can as well have C5H10O. Then come up with the following. CH3, CH3, CO, CH2, CH2, CH3. Those are 5 carbon atoms and 10 hydrogens. Then I can also have 4 carbon atoms, CH3, CO, 4 carbon atoms, CH, CH3. Create a branch here. That one. You can count the carbon atoms. There are 5 hydrogens. There are still 10. So these are still chain isomers. Chain isomers. Then for functional group, for functional group, isomers, I have C5, H10, O. Here, isomers define the position of the functional group. So I can have CH3, CO, CH2, CH2, CH3. You see, the functional group in this case, CO. CO is at position 2. This is 1, this is 2. Then take another example, CH3, CH2, CH2, CO, CH2, CH3. In this second example, the functional group CO is at position 3 when you count those carbon atoms. So here they define the position of the functional group, and we call this position position isomers. Position isomers. Then finally, for functional group, they differ in the type of the functional group. So here I can have aldehydes and ketones. Don't forget from our first video, if you haven't watched the first video, I recommend that you watch that video. From our first video, consider that first video, we saw that aldehydes and ketones have different structures. They have different structures, therefore their functional groups can be distinguished. So implying that if I can distinguish between their functional groups, those functional groups are different. Therefore, the functional group isomers, I can have a ketone and an aldehyde. By the fact that generally they have different structures, those two structures can be distinguished using different reagents. So out of C5H10, or I can formulate an aldehyde CH3, CH2, CH2. Those are how many? 1, 2, 3, 4, 5. Which is an aldehyde ending with CHO. Then generate a ketone CH3, CO, CH2, CH2, CH3. Those are 1, 2, 3, 4, 5. Those are 5. Carbon atoms, hydrogen atoms are still maintained. So you can see that here the functional group is CO. In simple terms, for ketones, the carbonyl carbon is within the chain, is inside the chain. However, for aldehydes, if you go from the first video, this is how they look like. The functional group is always towards the end. So these functional groups are different, and these are the functional group isomers. So in this video, I have reviewed isomerism within organic compounds, and I have also ensured that I've also made you believe that out of the general representation of a particular compound C5H10O, we can generate chain isomers, position isomers, and functional group isomers. As an activity, as a simple activity, you can think about isomers that can be generated from still in relation to carbonyl compounds. And also I want to say that these are not only the isomers which we can generate. Yeah, we can have a lot of other isomers. We can have a lot of other isomers, like for position, we can also have aldehydes. Yeah, but these are the basic ones which I've been able to illustrate. So still you can think about isomers which can be generated from C6H12O. As of now, I stop here, and in the next video we shall look at something different.